Space Telescope. And today is launch day. From all of the people all around the world working on today's launch, good morning, bonjour, buenos dias. This is live coverage of the historic launch of the James Webb Space Telescope. I'm Michelle Thaler, speaking to you from NASA's Goddard Space Flight Center in Greenbelt, Maryland. And I am very excited to be with you today. Today, the James Webb Space Telescope begins its journey to explore the edge of our observable universe, and its journey into history as well. This launch has been years in the making, and the world has turned out to watch. We'll have a lot to discuss both before and after launch, but let me set the scene for what's going on around us. While I'll be anchoring coverage from here at NASA Goddard, the big stuff happens today here, at the Centre Spatial Guyanais, the Guyana Space Center in French Guiana. This is the main launch site for the European Space Agency, a close partner in this once-in-a-generation mission, and the home of all Ariane launches. Katie Haswell is there at the launch facility and joins me now live via satellite. Okay, how are things in Peru, Katie?
Michelle, things are looking really good. The boards are green. The mission controllers are focusing hard. We are go for launch. We've had our eye on the weather the last couple of days. The weather's been a little bit inclement, so we're keeping an eye on that. But otherwise, everything's looking absolutely great. And I have to tell you, there is just such a buzz of excitement here in the Mission Control Center. It's a remarkable feeling. Right now we're topping up the tanks on the upper stage of the vehicle. So we've got two great big arms called cryogenic arms, and they clamp onto the upper stage and they pump in the cryogenic fuel, which has to be kept very, very cold. So it has to be topped up right until the last minute because it can evaporate. You'll see those arms kind of falling away just before launch in the last couple of seconds. So up here in the Sky booth in the Mission Control Center, we have NASA's Rod Navius and the European Space Agency's Luce Fabregat. They're standing by. Hi guys, standing by to take on the commentary when we get to about 15 minutes to launch. But right now, Michelle, all the boards are green. We're go for launch. Back to you, Michelle.
We'll be coming back to Katie for the final phases of the countdown in just a little bit. So, I'm an astronomer, and this launch is a huge deal for me. I am personally really excited. But why is this such a big event for everyone? The Webb telescope is nothing less than humanity's next effort to move closer to understanding some of the biggest questions about the origin of our universe. And it's not just the origins of distant stars and galaxies, but it's the story.
Right now, Michelle, all the boards are green. We're go for launch. Back to you, Michelle.
Speaking of questions, we'd like to include yours in this historic event. On whatever platform you're watching our coverage, drop your questions with the hashtag AskNASA. Later in the broadcast, we'll answer some of them live on air. It can't be said enough that this is a mission for anyone who's ever looked up at the night sky and wondered. People all over the world are sending in their best wishes for the success of Webb. And let's look at some of them now. It is not just the origins of distant stars and galaxies, but it's the story.
제임스 웹 우주만환경 행운입니다.
Boa sorte. Webbকে অনেক অনেক শুভকামনা.
Veel succes, Webb.
بالتوفيق لويب.
Kongo inorimasu, Webb.
Later in the broadcast, we'll answer some of them live on air.
हार्दिक शुभकामनाएं.
Mission for anyone who's ever looked up at the night sky and wondered. People all over the world are sending. We're still on track for a launch at 7:20 a.m. Eastern U.S. time. 2 days ago, the rocket rolled out to its launch pad in Kourou. Of course, there's already been a lot of activity at the launch site. Primary fueling procedures were completed early this morning, preparing the giant Ariane 5 rocket for flight. Let's watch this scene for a moment. know the world is watching. Today, humanity begins its next bold adventure to extend ourselves out into the cosmos. This is something we do as a whole planet, all of us together. Befitting the global importance of this initiative, let's review some of the basic facts about the observatory shared by people all over the world who are looking forward to the Webb mission.
The entire world is looking forward to the launch of the James Webb Space Telescope. Let's hear more from people around the globe about what makes Webb a scientific and technological marvel.
Será el próximo y principal observatorio espacial para los astrónomos de todo el mundo y llevará más allá los prometedores descubrimientos del telescopio espacial Hubble.
它是一个由美国国家航空航天局、欧洲空间局和加拿大空间局开展的国际合作项目。
Ni darubini kubwa zaidi kuwahi kuwekwa angani na ina nguvu.
The European Space Agency and the Canadian Space Agency are the principal players. But a vast core of engineers, scientists, private companies, and more have had a hand in building this one-of-a-kind scientific platform. Without a doubt, this is the most complex spacecraft ever built, with revolutionary technologies, daring mission goals, and a whole lot of personal passion and commitment. We'll hear from our partners later in the broadcast, but first, let's hear from someone representing the science community with a rare perspective about space exploration.
Hello, I'm ESA astronaut Matthias Maurer, currently living and working on the International Space Station ISS. I'm very excited to follow the James Webb Space Telescope's launch with you all from space. Even with the naked eye, we astronauts see that the stars are incredibly sharp and brilliant once we are outside the Earth's atmosphere. James Webb Space Telescope will be the largest and the most powerful telescope in space yet. And it was built to study the big questions. Questions like, where do we come from? How did galaxies form, like our Milky Way? How are stars and planets born, like the Sun and the Earth? Might there even be life on other planets? The James Webb Space Telescope is a joint project between NASA, the European and the Canadian space agencies, and by tens of thousands of people with origins in many countries. And it will be used by scientists everywhere on Earth.
NASA Goddard is the home of the Webb telescope, with big sections designed and built here. But actual mission operations take place here. This is the Mission Operations Center, or MOC, at the Space Telescope Science Institute in Baltimore. After launch, this facility will command and control Webb for the duration of the mission. We'll be looking at the MOC at key moments throughout the broadcast, and this will become a familiar location for viewers in the weeks ahead as the Webb team begins to set up the telescope for work in space. So as we move closer to launch, we'll actually keep a picture of the launch facility right here on the screen. But for the next 10 minutes or so, we're going to talk about some of Webb's principal science goals. If you've ever seen a telescope before, I'm certain it didn't look like this. Of course, the look of this particular machine is a direct result of the scientific questions it's been built to pursue. So fortunately, we've got an expert pair of guests with me this morning to help explain those science goals and much more. So I'm joined now on the set by NASA's Deputy Project Scientist for Exoplanet Science, Nicole Colon, and also with Macarena Garcia-Marin, the Instrument and Calibration Scientist for Webb's Mirroring Instrument from the European Space Agency. So welcome to you both.
Thank you. Good morning. Thank you.
So this is our chance to kind of step back and talk about the science goals of Webb. You know, this is the part that really excites astronomers like all of us. And I know that there's unusual things about it being an infrared telescope. There are specific science goals, infrared answers. So maybe you could start us out, Nicole, with you're an expert on exoplanets. How is the infrared really important for your study?
Sure. Well, with exoplanets, we want to study their atmospheres. And as a reminder, exoplanets are planets that orbit distant stars. So we're looking for very small signals when we study their atmospheres. And Webb is this giant telescope that we're able to use to collect these small signals and look for infrared signatures, chemical signatures of water and methane and carbon dioxide, those types of molecules in their atmospheres. And why the infrared? You know, that's really because those signatures are the strongest in the infrared. We know that they exist there, and so that's why we want to use Webb to look there.
It seems an amazing idea. So exoplanets, planets around other stars, are light years away from us, tremendously distant. So how do we know if it's water, methane? I mean, how can we probe an atmosphere so far away?
Well, with Webb, there's a couple different ways, but one of the main ways is actually using the transit technique. And this is an indirect method where we actually detect the decrease in starlight that happens as a planet goes in front of its star. But then imagine the planet has an atmosphere. Well, there's an additional decrease in the starlight because the atmosphere blocks some light from our point of view. And why it blocks the light is because there's usually a molecule or something in there, like water and methane, like I mentioned, that is acting as an absorber and blocking the light from our telescope, in this case, Webb.
So going from, the relatively nearby stars and planets, Macarena, you're an expert on very distant things, distant galaxies. So how does infrared contribute to your field of study?
So with Webb, we're going to be able to observe the very first galaxies and stars. We're talking about 3.5 billion years ago, so it's really mind-blowing if you think about it. And why infrared? Well, those galaxies emitted their visible light many, many millions of years ago, and that light travels towards us in time, and at the same time, the universe expands. So in that process of travel and expansion, the light shifted from the visible to the infrared, and so Webb will be able to actually observe those very original primeval galaxies. And not only those, but it will also allow us to observe everything in between, so we can understand the evolution of our galaxies from the first ones to the ones we see today.
This is something kind of amazing. So our eyes interpret different energies of light as different colors.
Exactly.
And infrared light is a color that our eyes are not sensitive to. But like you said, it's actually just the space of the universe stretching out the light and changing it from visible light into infrared.
Into infrared, exactly.
So how are these first galaxies different from galaxies today?
Well, when you look at the images we have of the oldest galaxies we've seen, they look like fluffier and clumpier. We know they have a lot of star formation, so they are actually, that's a really good signature to measure them. And they are like little seeds that afterwards they merged and got together and evolved until the ones we see today, which are like spirals and elliptical galaxies.
So from the near universe to the far, one of the things that infrared is very good is seeing through dust. That's another huge advantage. Maybe Nicole, could you sort of take us through that story?
Sure. With dust, first there's a lot of dust in the universe, but how stars and planets form in the first place, they are forming in these very dense clouds of gas and dust that come together, and it's very difficult to see through them with normal visible light. And so the infrared is actually able to see through that, almost like an X-ray, sees your bones, sees through our skin. You can use the telescope like Webb to see through the dust and see the inner stars forming, or see some newly formed planets that are also very warm from having just formed.
And there's even a possibility of seeing some of the very first stars, or at least some evidence of the first stars that might have existed. But could you tell us a little bit about that, Macarena?
Yeah, so the very first stars, they form right around the time of the very first galaxies, even before that. And so we'll be able to measure them, maybe not the very first one, but the first population of stars, which is really interesting because they were formed out of a very pristine material. And then from there, they evolved into more evolved stars that created all the elements we know today, things like gold, platinum, carbon, everything. Us were formed out of those original stars. So it's a really amazing adventure to observe all these objects and understand them better.
There's so many wonders in the universe, and one of the things that I would never have believed was real unless I'd seen the data with my own eyes, is the TRAPPIST-1 system. And that this is actually going to be one of the targets for Webb, is that right? Tell us a little bit about TRAPPIST.
Sure. TRAPPIST-1 is, like you said, it's going to be a target. There's 7 planets in the system, and they're all small, around the size of Earth, actually. So it's also a very compact system. So it's not just that there's
one before. It's taken years to prepare it for flight, and as you might imagine, plans of this scope and scale inevitably run into unexpected challenges. Along the way, just like any of us, it encountered things like snowstorms in the east, wildfires in California, hurricanes that deluged Houston, Texas, and of course, the global COVID-19 pandemic, which added its own profound challenges to the whole team. This story really warrants a recap, so check this out.
The Webb Space Telescope presented many engineering challenges, but engineering hasn't been the only obstacle the team had to overcome. In 2011, an outbreak of tornadoes cut electricity to the Marshall Space Flight Center in Alabama for nearly a week, while the team rushed to finish cryogenic testing on the primary mirror segments using power from diesel generators. Engineers had to endure a large snowstorm, known locally as Snowmageddon, while testing the integrated science instrument module at the Goddard Space Flight Center. And of course, everyone has had to contend with the global pandemic. One particularly memorable challenge was working through Hurricane Harvey in 2017. This massive cyclone dumped 40 to 60 inches of rain across the Houston area over a 4-day period, causing catastrophic flooding and $125 billion of damage, all while the telescope was undergoing cryogenic testing at NASA's Johnson Space Center. Though the telescope remained safe inside the test chamber, water leaked through the ceilings, people had to cover workstations in plastic tarps, food was in short supply, and a few team members trapped by flood